Okay, now for something completely different. This is the first of the problems from homework set 42, page 647, problems 24 and 25. You've got problems 23 and 32 assigned as sisters. And maybe you've noticed we've just jumped 100 pages or so from the last previous homework set. And that's because we've jumped from chapter 8 into chapter 10, skipping right over chapter 9, which is about a nice topic called vector analysis. It's a shame that you have to miss that, but it's not part of the curriculum for this class. We're in the curriculum associated with conic sections, and the first of the four conic sections is the parabola. And so these two problems both say find the equation, find the endpoints of the lattice rectum, and do a graph. So what the heck is problem 24? I need to get on the right page here. Problem 24 says, I'm thinking of a parabola and it's got a focus at -4, 0, and it has a vertex at the origin. So let's find the equation, find the endpoints of the lattice rectum, and graph it. So this is actually quite a lot of information. If I just go ahead and draw a Cartesian plane, x and y, and I count off 1, 2, 3, 4, that point is the point -4, 0. And that tells me just about everything I need to know, because the focus is inside the parabola, right? And the vertex is at 0, 0. So this parabola, I'm kind of doing this work backwards, has a graph that looks like this. Right, and oh, by the way, it has a lattice rectum with a point there and a point there. We'll work with that for a second. First of all, what's the equation? Since I'm dealing with a horizontal parabola, it is of the form y minus k squared is equal to 4a times x minus h squared. Looks complicated, it's not. Let's just remember what these quantities are. H and K. HK is the ordered pair associated with the vertex. That's a long way to say that the vertex is at the point HK. Okay, this quantity A is the focus, focal length, which is the distance between the vertex and the focus. Vertex to focus. And, that's it. That's it. The y squared, the square is on the y since we're horizontal here. The only other thing you have to make note of is that this focal length actually carries a sign. If it's positive, we would open up to the right. This one's negative and opens up to the left. So if I'm going to specialize this particular case, h and k are both equal to 0. This is the point A0. So that means this is the equation. The equation for this is y squared is equal to -4a, not a. It's -4 times 4. Focal length a is -4, so it's 4 times a, 4 times 4x, minus 16x. Okay, y squared equals -16x. That's problem 24. Do I need to do anything else? Yeah, I have to go find this point. Yeah, so how do we do that? What we do is we insert the point x is equal to -4 into this, solve for y. So if y squared is equal to -16x and we put -4 in, then y squared is equal to -16 times -4, that's 64. Let me take the square root. That says y is equal to plus or minus 8. And so these points here are -4, 8, and -4, -8, the endpoints of the lattice rectum, which is the segment that runs perpendicular to the axis and through the focal point. It's this green line right here. All right, I'm ready to sign off, but I've got another problem to do, don't I? I've got number 25 to do, so let's see what 25 has to share. Again, we're going to find the equation, we're going to find the endpoints of the lattice rectum, and we're going to graph it. And 25, 25 says, it says the focus is at -2, 0, and then it says the, where are you, 25? It says the directrix is the line, x equals 2. X equals 2. Okay, so let's do this again. Draw this. Let's go find the focal point, which is -2, 0. Let's draw the line x equals 2. That line is the directrix. And what do you know? The vertex is the point which is equidistant from the direct. The vertex is the point on the parabola. All points on the parabola are equidistant from the focal point and the directrix. In this case, since the axis of symmetry here is the x-axis, the vertex again is right here, 2 steps away from the directrix and 2 steps away from the focal point, and therefore again we're looking at a parabola that looks like that. It has a lattice rectum right here. It's of the form y minus k squared is equal to 4ax. A is equal to essentially -2. Sorry, this is x minus h. H is equal to k is equal to 0. That is the x and y coordinates of the vertex are both 0. And so this specializes to y squared is equal to -8x. And that indeed is the answer to problem 25. All I have to do now to finish things off, because we've done the graph, is to insert into this x is equal to -2, and I will say that y squared is equal to -8 times -2 is equal to 16, which says that y is equal to plus and minus 4. And so this point right here is -2, 4. There's a minus sign right there. And that point is -2, -4. And that resolves and completes these two problems.